Boop. All right, let's look at B over here just to talk through this a little bit because we didn't get to this one yesterday, but let's just do B because they love to toss this one random weirdness at you. So we've got that we're trying to find the area of the sector that has, love that. Fun times. Let's try that again. Oop. Would y'all talk to each other, please? Oh my gosh. Let me see if I can access it the other way around. Nope, that's not what I wanted. Go back. There we go. Okay, fine. Workaround. So we're gonna do B. Oh, that pen is so much skinnier. Oh my gosh. We're not gonna do it. We're gonna do B just because we don't need to do too many of them. I don't want to use all of our time. We got things to do. But we're asked to find the angle in both degrees and radians and the area of the sector. They've given us an arc length of 3 feet and a radius of 20 inches. What should we do first? Get them into the same gosh darn unit. Because this arc length, what is 3 feet in terms of inches? 36 inches. You can absolutely put 20 inches into feet if you're really feeling like it. A little harder, you'll have decimals. Not wrong, just weird. But if you want to rock the weird, go for it. Fully support it. Okay, so get them into the same units. I'm pretty sure there was one on the homework that had different units like that. So then let's figure out our angle. So I've got S, I've got R, we want to know theta. So I'm going to use my arc length formula. So I know my S is 36. And that's going to equal our radius of 20 times our theta, which we don't know. What do we do to find theta? Divide by 20. What do we get when we divide by 20? Say it again. Oh, 9 over 5. I thought you said 9.5, and I'm like, oh, what? 9 over 5, yep. And we could absolutely leave that as a fraction if you'd like. You could also put it as a decimal for this since we're working with it, but 9/5 is a fine unit. What kind of measurement is this? Is this radians or degrees? Radians. It's in radians. So we also want to find our degrees because they specifically asked us for that. So if I want to get my degrees, stop it. There we go. What do I need to do to that 9/5 in order to get it to be degrees?
Multiply it by
180 over pi. That switches it from radians to degrees. And we do want to get a full, like the actual decimal on here. Give me 2 decimal places. Hello, darling. Thank you. Yeah, 100 and what? Okay. I was going to say, I thought I heard 30, but I'm like, I thought I had 103, but I also am prone to make mistakes typing it. So we've got our radians and we've got our degrees. The next thing we're asked for is the area of that sector. So we're going to find our area using the area formula, this guy over here. So our area is 1/2 times that radius squared times our theta. What's up?
Oh, so the R is in radians?
The R is our radius. Theta is our angle. Theta is always an angle. Angles are written with Greek letters. Sides are written with English letters. So the R is going to be a side. It's our radius. The theta is where we get our angle. So theta is going to be our radian angle. So we're going to use our 9/5. And we're going to multiply that. We'll get our 20 squared, which is 400.
360?
Times 1/2 times 9/5. We're going to get an area of 360 what? Inches squared. Okay, you do need to make sure to have your units on things. So we did all of this part, like finding, like using these things yesterday. We just didn't get to actually substituting into this equation, and I wanted us to see that at least one time and try and make sure we do everything at least once together. So it's just substituting in, and we can type this in the calculator. We can do it by hand. 20 squared gives us 400 times 1/2 gives us 200. Like, we can do it. But just one of those, I wanted to do it once. Questions on that one? Okay. So that is the end of section 6.1. So if you did not do the area questions on the homework and you want to finish those up over the weekend and turn it in on Monday, totally fine. I won't give you late penalty on it. Totally fine. But if you've got it done, turn it in. Like, also fine. I always give at least a day of wiggle room on homework assignments. I am going to try and be more on top of like things being on time this semester, because last semester I was really, really lax on it. So I'm going to be a little bit more specific with dates. Okay? So we're going to go on to section 6.2. I'm going to try and get my screens to talk to each other again now. Of course, that part's going to work. Of course, that part's not going to work either. Love it. Let's see what's going on. It's probably on my computer that's being a jerk. There's probably an error message somewhere. So what we're going to do is we are going to get our, what's up? No, that's because I turned it off. I turned off the presentation. This is on the Google slide. We are going to take a look at our unit circle for the very first time. I am going to pass these out. I'm just restarting that program. This is going to be a thing you're going to memorize. Oops, sorry. Going back. You are going to need to memorize this. Not even kidding. We are going to do speed tests on it. 3 minutes. We get 3 minutes. I was like, and what it'll be is I will hand you one of these. It'll be blank. And you have 3 minutes to fill it in. Entirely. All the blanks. Huh? All of it memorized. You have to have this thing memorized. Not even kidding. We use this all semester long. This is not us being petty and trying to torture you. This is something we are going to use all semester long. To the point that even when I was doing like my grad school homework last semester, I brought home a unit circle and filled it in to use on my homework. Like, it's something we use all the time. Almost all of our answers for the rest of the semester are going to be something on this circle. So the ones that have the little circle on them, those are our degrees. So we're going to start at 0. We've got our 90 degrees. We've got our 180. So see if you can fill in some of those degrees while I try and get my computer and my iPad to talk to each other nicely. So see if we can fill in the degrees. The degrees are the insidemost piece. Yay! Got it. Now they're talking to each other. Love it. So we can't do everything on here yet, but we can do degrees and we can do the radians. We should be able to do all the radians, not some. So when I'm coming to fill these in, we can do our degrees first and then our radians. You can do them all at the same time. There's many, many, many different techniques to fill these in, especially as we get to the speed test. It's going to be important that we can do that. So our inside piece that has these little circles, that's our degrees. We're a lot more comfortable with them. This one you can put, and there's too many options for this one. You can put this as 0, I tend to. If you put it as 360, because we've gone all the way around, that is also okay. They are coterminal, totally fine with that. Same thing with our radians. If you put this as 0 or if you put this as 2 pi, those are both correct, totally fine. We'll go through radians again in a second. I'm gonna do degrees first. So we're gonna have our 0. We know this one up at the top here, that guy's 90. If I come all the way over to my straight angle, that's 180. And down at the bottom, we're at 270. All right, those should be not question marks. Halfway between 0 and 90 is going to be what? 45. Halfway between 90 and 180 is another 45 degrees, right? 135. Halfway between 180 and 270, 220. 225. I was gonna say. I was like, I knew that wasn't right, but my brain was not braining. 225. And then our last one on these kind of 45s, the halfway betweens. 350. Okay, so that's the way I'll do my 90s, then I'll do my 45s. The next one I'm going to do is actually going to be the ones in between. This is my thirds. If we think about this, I'm going to draw some lines on here. I'm going to erase them in a second. Oof, I'm going to do a chunkier pen. If I think about this semicircle and cutting it in thirds, right here, right? That's cut in thirds. What is 180 degrees cut into thirds? 60. So this guy's going to be 60. This one, because it's in thirds. This is 1/3 of the semicircle, and this is 1/3 of the semicircle. Okay, so cutting it into thirds. So if I count up by 60s, so we have 0, 60. What's going to be our next one in the thirds? 120. And then we wind up at 180. What's our next one in the thirds? 240. And then our next one in the thirds, 300. And then that would get us back to 360. All right, we've got one more line in here. It's not 20, but I see what we were thinking. What it actually is if I take my 60 and it gets cut in half, it's 30. It's half of 60. So what this is going to be is it's sixths. So this is going to be 30 degrees. So this is counting up 30. Then we'd get to 60 would be the next 30. Counting up to 90, there's the next 30. So that's 1/6, 2/6, 3/6, 4/6, 5/6, 150. Oh, do you need me to zoom in? I was gonna say I can zoom into the top half if that would help. Okay. This one is counting by 30s. 30, 30. So it's dividing that quarter into thirds, which is dividing the semicircle into sixths. Oh, that was definitely meant to be the eraser. I was gonna say, it's one of those things we're gonna get used to it. We're gonna see this a bunch of times. So let's keep going. What's our next sixth here? 210. So we're adding 30 to get to 210, adding 30, that would get us to 240. Adding 30 would get us to 270. Adding 30 gets us to 300. Adding 30, 330. And that is the order I tend to do them in. I tend to do, like, I'll do my 0, 90, 180, and I will also at that time do my radians. When we get to our ordered pairs, we'll get those. We're not there yet. But that's all of our degrees. What's up? This is going to be before February 8th. This is going to be one of those things we're going to do speed quizzes on. Because we need to be able to fill the whole thing in 3 minutes.
So will we have like
Yes. And on the calendar thing, our first unit circle quiz is not until... nope, that is the chapter test. Unit circle quiz on the 23rd. So like right when you come in, I'm going to hand you a blank one of these. I'll start a timer on the board for 3 minutes. And it is either all correct or it is not. It has to be perfect. And we will do that. We have 3 of them scheduled in class to do. And if it takes more attempts, that's fine. You're just going to come in and either do it after school or during 5th period sometime and do it that way. But it's a 3-minute perfect or not. Because, not even kidding, I'd say after this chapter, 90% of our answers are going to come straight off of this. We'll need to know how to find them, but the answers are coming from here. So this is a super important tool for us to have. And you're not going to have time on that speed quiz to be able to type things in the calculator. It has to be memorized. It's 3 minutes. You do not have time to try and calculate anything. You barely have time to write the things. Okay, so we need to know this. So the next thing we're going to do on here is I'm going to put my radians in. I'm going to put the radians on these little lines right here. If you put them next to it, that's totally fine. If you put them somewhere else, just make sure it's clear. And I'm going to fill them in kind of that same order. So, yes, dear. The lines will be on there. It'll be this exact one, except instead of where it says unit circle fill in the blank, it's going to have name, period. I was like, I think it's slightly better quality, as in the lines are not so fuzzy, but it's this. All right, so when we're looking at our radians, it starts the same way. We have 0 over here, and half of a circle is pi. I was like, if you marked it as 2 pi over here, I'm okay with that. It's not wrong. I just tend to put 0 because I start there. So if we know this is 0 and this is pi, this one is going to be half pi or pi over 2. If you choose to use this little line as a fraction bar, that is totally okay. You don't have to. If you want to write your whole fraction on top of it, that's okay too. I tend to do that just because my marker is chonky. So if we know that that's pi over 2 up on the top, down here at the bottom, 3 pi over 2. I'll put this one on top just because that bar is really close to the bottom. 3 pi over 2. Oh, it's because I'm on the chonky pen. That would be why. I'm like, why is that so big? That is not the eraser. 3 pi over 2. There we go. That's a better size. Okay. So we've done a couple of these. But let's think about it. If we have our pi over 2 up here and our 0 here, what's this guy going to be? Pi over 4. Yep. So this is pi over 4. What might this next pink one be? Yeah, 3/4. So I'm going to put it as 3 pi over 4. So 3/4 of pi, or 3/4 of pi. It's 3 pi over 4. What about this one? The next pink one, sorry, I was turning my page back. I want to like double, triple check that I don't give you wrong information, because that would be like Horrible. This one. 5 pi over 4. That's not a pen. 5 pi over 4. So we're counting up by quarter pies, really. So this is 1/4 pi, half pi, 3/4 pi, pi. 5 pi over 4, 6 pi over 4, 7 pi over 4. So then I'm going to do my purple ones. These guys. How much of a pi?
Pi over 3.
It's 1/3 of our semicircle. You remember the purple pieces? If I grab that. The purple piece is looking at this guy. If I divide up my semicircle, I have 3 chunks. So this is pi divided into 3 pieces. So this is pi over 3. Which means, what's this one? 2 pi over 3. I have 2/3 of the pi. 2 pi over 3. 3 pi over 3 gets us back here down to pi. So that would be 1 pi. So if we're going 1 pi over 3, 2 pi over 3, 3 pi over 3. What's that guy?
4 pi.
4 pi over 3. What's this one? 5 pi over 3. And that would get us back to our 6 pi, which would round up right here on our 2 pi. All right, one more section. Because this 30, it's half of our 60 degrees. This is pi over 6. Pi over 6. So we have our 1 pi over 6, 2 pi over 6, which is the same as pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6. And then again, we're going to have 6 pi over 6. That gives us pi. Ooh, snap. 7 pi over 6. And then we'd have our 8 pi over 6, which would simplify. 9 pi over 6, which simplifies. 10 pi over 6. 11 pi over 6. I already heard it said once, that's why I just kind of plowed through it. So 11 pi over 6. Okay, so there's a lot of pieces in there. And I believe on Monday, we will get the other values to fill in our ordered pairs. But so we can start looking at this and thinking about it and seeing if we notice any patterns. There are many different thought process techniques, tricks, tips, whatever, for how to fill in the unit circle quickly. And I will show you a couple of them as we get closer and closer to the unit circle tests. But there are so many different techniques and options on there. If the things that we do don't work for you, feel free to check out YouTube. Khan Academy has some good ones too. There's lots and lots of options for how to be able to do this quickly. We need to have the unit circle and have it available for us. Whenever we have things like quizzes, tests, and whatever, I'm always able to give you a unit circle, but whenever I hand you a unit circle, it's going to be one of these. So if you ever are trying to look at it or think about it, I'm handing you a blank one. So you got to be able to fill it in. Okay? So I wanted to give you that so we could start thinking about that, having it processed through our brain so that we're not trying to look at the whole thing all at once and it was magic that filled it all in. Okay? So just little digestible chunks. We'll get the ordered pairs later. We will fill those in. So you'll have to do all the pieces, degrees, radians, and ordered pairs in the 3 minutes. But we'll get there. Okay? Questions on unit circle as it sits right now? Question or stretching? What's up?
Can I get extra sheets?
Yes. Yes. this. And I will always have gabillions of them. And next week I'll have a bunch of them printed out, and I will have extra unit circles. I'll put them in this pocket right here. And if you want to grab a stack of them at any point, feel free. I will print out bunches and bunches, just so that you have them. Okay? So the other thing we're going to use a gabillion of this semester are going to be our trig functions. So a lot of these we should know, but I did find out last year that some of us have never seen some of these. So we're going to talk through them all. SOHCAHTOA, yes. All right, so we should know these left ones for sure. Sine, cosine, and tangent, those are our big main three. So when we're thinking about our SOHCAHTOA, what does that mean? Sine is the opposite side over our hypotenuse. So sine of an angle, we're looking at the opposite over the hypotenuse. These are all relative to a right triangle. So I've got a little sketch of one down here. If we're looking at this angle here, this side is our opposite. This side is our hypotenuse, the long one. What is this? In this case, it's our bottom side. What is this side called? Adjacent. The adjacent side. So it's all relating the sides of our triangle to the angle in there. So I'm going to just switch that out so it's color-coded still. Hypotenuse. All right, so we've got sine. What's our cosine? Adjacent, so ca, C-A-H, ca. Adjacent over hypotenuse. TOA, tangent. Opposite over adjacent. Okay. How many of you have seen these ones before? Okay, awesome sauce. So, this first one, CSC, this is called cosecant. I'll write it down. Cosecant. And what it is the reciprocal of sine. They are buddies. So if sine is opposite over hypotenuse, cosecant, flip it. Hypotenuse over opposite. The next one, SEC. Just like we have sine and cosine, we have cosecant and secant. And again, just like cosecant is the inverse of sine, secant is the inverse of, or not inverse, reciprocal of cosine. So secant is going to be hypotenuse over adjacent. And again, we've got tangent, and now we're looking at COT, cotangent. And again, it's a reciprocal. So if tangent is opposite over adjacent, cotangent, adjacent over opposite. They're all flipped from each other. We are going to see these 6 trig functions a lot. pretty much everything except the last chapter, and even that's going to use these a bit. But everything between now and then is going to use these a gabillion times. Gabillions. So these are called reciprocal identities. And I'm just going to write them to the side because I did not give myself any space to the side. Because cosecant, again, remember that's the same thing as the inverse of sine. Or the reciprocal, not the inverse. Gosh, I keep saying that. Reciprocal the same. So cosecant is the same as 1 over the sine. Secant is the same as 1 over cosine theta. And cotangent is the same as 1 over tangent of theta. They are reciprocals of each other. So those are our reciprocal identities. We're going to use these in a lot of things. So you could write these in the opposite direction too. Sine is the same thing as 1 over cosecant. Cosine is the same as 1 over secant. Tangent is the same as 1 over cotangent. It can reciprocal the other direction as well. And a good way to kind of help remember which one's paired up with which is each pair only has one co. So sine, cosecant. Cosine goes with, change colors. Cosine goes with secant. Tangent, cotangent. So each pair only has one co. Sine, cosecant. Cosine, secant. Tangent, cotangent. Each pair only gets one co. So don't put cosine and cosecant together. That's the most common mistake we get is because they're like, cos, they go together. Everybody gets one co. Okay? So these are things we are going to use a gabillion times. And we're going to practice with it here. We got time. Still got 10 minutes. Good. Okay. Everyone get these written down? Because these are super important. All right. We're going to be given problems like this. We're going to find all 6 trig functions. When we're given some information, we might be given a picture. We might be given a piece of a trig identity. We might be given an angle. We might be given some sorts of things. What we're looking at here is we're looking at this angle. And if they don't give you a triangle, I highly recommend drawing a picture and picking an angle. Label it, tell you what your theta. We know that this side is our opposite from the angle that I picked us here. This side is our hypotenuse. And then we're going to have this side being our adjacent. And they've told us our cosine is 3 over 4. So cosine is made up of which 2 pieces of the triangle? Cos, so cos, C-A-H. Adjacent over hypotenuse. So what that tells me is that my adjacent has a length of 3. So this guy's 3. My hypotenuse has a length of 4. How can I figure out that other side of this right triangle? Pythagorean theorem. So I know right triangles. That only works if 5 is your hypotenuse. A squared plus B squared equals C squared. Which piece is C?
4.
The 4. The hypotenuse is your C. The 3, is it A or B? Or does it matter? It does not matter. Even a little bit. Put it as A, put it as B, it don't matter. I'm going to put it as A because you were very passionate about it. A squared plus B squared equals C squared. 3 squared plus something squared equals 4 squared. So 3 squared gives us
9.
9 plus something equals 16. So what is b squared going to be? B squared is 5. So b is the square root of 5, which is ugly and not 5. Not 5. What should it be? 7. It's like, call me out on that. I went with what y'all said. All right, so I was going to say, I was just like, wait a second. That doesn't match up with what I have. Y'all, the ADD is ADD and hard today. So this tells us our other side. This is the length of my opposite. So this guy has a measurement of the square root of 7. And I'm writing it sideways. Just no. Oh, 6. So we need to find the side so that we can use that to find all of our pieces. We're going to find the sine of theta. So sine is made up of which two pieces? Opposite over hypotenuse. So opposite is the square root of 7 over our hypotenuse, which is 4. Sine of theta. Cosine is, so ca, adjacent over hypotenuse. A great way to double check if you just go through all 6 again. So our 3 over our hypotenuse, which is 4. Excellent way to double check because it's exactly what we were given up here. We got 3/4. We started with 3/4. Awesome sauce. We're in good shape. Tangent. TOA. So we've got opposite over adjacent, right? So our opposite, that's our square root of 7, over our adjacent, which is 3. Okay? To find our other 3, we're going to use the fact that they're reciprocals of each other. Bring it back, bring it back. There we go, we're back. Okay, so sine goes with cosecant, because each pair only gets one co. So cosecant of theta is, and we're going to flip it upside down, 4 over square root of 7. Do we get to have square roots in the denominator, though? No. What do we do? Not square the top and the bottom. Times by square root of 7 over square root of 7. We got to rationalize our denominator. So times our square root of 7 over the square root of 7. Because we don't want to have square roots on the bottom. So we're going to have 4 square root of 7 over 7. So all that rationalizing that we did last semester, yeah, that's going to happen again. All right, so then let's do secant. Remember, that's the reciprocal of cosine. So that's going to be 4 over 3. And cotangent, last one for today. We're going to take our reciprocal of tangent, so it's going to be our 3 over the square root of 7, but we can't have square roots in the denominator, so we need to rationalize it. Same way we did for cosecant. So it's going to be 3 square root of 7 over 7. Okay? So you have just found your first set of all 6 trig functions. You got to do that so many times. Okay? So I'm going to put up the homework assignments. These dates are wrong still. I have not gone through and updated things with proper due dates because of the snow day at the beginning. 6-1, again, technically it's listed as due today, but since we didn't get to that area formula until today, if you want to turn it in on Monday, totally fine. If you figured out area formula and you're ready to turn it in, you don't got to keep track of it then, and I'll keep it. Okay? Please make sure you register for the IU section of this course. You should have gotten an email from ACT that'll give you a direct link, or there's a link on the Canvas page, or you can go to the IU ACT website. But all that jazz. Okay? Have a great weekend. You made it through the first week of the semester. We did it. Okay, yes. That should be in good shape.